everyone, welcome back. This is lesson 8.2, multiplying and dividing rational expressions, part 1. The objectives for today, you're going to be able to simplify rational expressions and be able to multiply and divide rational expressions. Your vocabulary for today is rational expression. All right, in this warm-up, I just want to remind you of a few things that you've already learned. Number 1, x to the 5th times x squared, we know is x to the 7th. And y to the 3rd times y to the 3rd is y to the 6th. Next with division, x to the 6th over x squared is x to the 4th. And y squared over y to the 5th, we know is 1 over y to the 3rd. So just remember y squared over y to the 5th. We're going to have 5 y's on the bottom. 2 of them cancel out. That just leaves us with 1 over y to the 3rd. All right, now when we're going to factor, let's remember that when we factor, we take a look at this term, and we say, okay, what two numbers multiply together to get -8, add together to get -2? And I know that's -4 times a +2. And so now when we factor it out, it's pretty easy. X minus 4 times x plus 2. And if we FOILed it back, we would end up with our original equation. In problem number 6, I see that I can factor out an x is common in both of those terms, leaving me with x times x minus 5. And the third term, notice I can take out an x to the 3rd out of each of those terms, and that would leave me with, let's see how we got to that one. If I take an x to the 3rd out, that leaves me with x squared minus 9, and I see that that's the difference of two perfect squares, which is x plus 3, x minus 3. And so here's how we get our last answer. All right, in lesson 1, you worked with inverse variation functions such as y equals 5 over x. The expression on the right side of the equation is called a rational expression. A rational expression is a quotient of two polynomials. Other examples of rational expressions include the following. All right, so notice the main thing that's common in both of them is this division, that they're all a quotient. All right, the quotient of two polynomials. Because rational expressions are ratios of polynomials, you can simplify them the same way you simplify fractions. Recall that to write a fraction in simplest form, you can divide out common factors in the numerator and the denominator. So for example, when I have a fraction that is 9 over 24, I can rewrite that 9 as 3 times 3, and 24 is 8 times 3. And notice 3 over 3 is the same as 1, so I can cancel those out, just leaving 3 over 8. So caution, when identifying values for which a rational expression is undefined, and we'll talk about that in a minute, identify the values of the variables that make the original denominator equal to 0. So remember, if we have a fraction like 5 over 0, that is an undefined fraction, that's undefined. All right, and we can't have that. And so you're going to have to be careful with what's happening down here in the denominator. In this example, we're asked to simplify first and then identify any x values for which the expression is undefined. So first of all, I know that 10 can be divided by 2 and 6 can be divided by 2. So 10 divided by 2 is 5, 6 divided by 2 is 3. Also, I see that I have 4 x's on the bottom and 8 x's on the top, so I can just cancel that using my quotient of power properties, and I end up with the fraction of 5 over 3 times x to the 4th. Now, I can't forget what the rest of my problem says. It says identify any x values for which the expression is undefined. So I need to think, what is x going to be? Is there anything x can be that would make this end up with a 0 in the denominator? And the expression is undefined at x equals 0. Why? Because way up here at the beginning of our problem, we can see if x is 0 down here, that gives us a 0 in our denominator, and that would make our problem undefined. All right, same directions. We're going to just simplify this and then identify any x values for which the expression is undefined. So first of all, in order to to simplify, I'm going to go ahead and make my x and say what two numbers multiply together to get -2, add together to get 1. Well, I know that is 2 and -1. So I'm going to have x plus 2 times x minus 1. And for my denominator, again, two numbers that multiply together to get -3, add together to get 2. That's going to be 3 and -1. So x plus 3 and x minus 1. So lucky here, I can cancel these two out, leaving my simplified answer as x plus 2 over x plus 3. Now here's where we have to be careful, because it says identify any x values for which the expression is undefined. So that means when I have a 0 in the denominator, that means my equation is going to be undefined. So let's set each of these two equal to 0. X plus 3 equals 0, or x minus 1 equals 0. So when x equals -3 or x equals +1, we're going to have either of those would equal 0, and that would make our equation undefined. So that's the answer to our question. The expression is undefined at x equals 1 and x equals -3, because these values of x make the factors x minus 1 and x plus 3 equal to 0. So when we're looking for the values at which the expression is undefined, we have to choose both of them. All right? All right, and we can also check this to make sure that we did. We can do that by going ahead and just substituting 1 and -3 into each of to our original expression. If we use 1, we see that we're going to get 0 over 0, which is definitely undefined. And if we substitute -3 into our original equation, we end up getting 4 over 0, which is also undefined. So both values of x result in the division by 0, which is undefined. All right, this is one for you to try on your own, so go ahead and turn the video off for just a minute and give it a try. Okay, in this problem, this is a pretty easy one to simplify. We know that 8 divides evenly into both of these, so 16 divided by 8 is 2, 8 divided by 8 is 1. Here I have x squared and x to the 11th, and so I know that my answer, that can go away, leaving me with 2x to the 9th. But I have to be careful because it says identify the values of x for which the expression is undefined. So remember, our expression is undefined when I have a 0 in the denominator. So my denominator was originally 8x squared, and so when x is 0, the whole denominator is 0. So when x is 0, that's the value for which the expression is undefined. So the expression is undefined at x equals 0 because the value of x makes 8x squared equal to 0. All right, so this is another one for you to try on your own. Turn the video off and give it a try. Okay, in this one we're asked to simplify. So the first thing we're going to do is take a look at our numerator, 3x plus 4, and I see that there's nothing else I can do to simplify that. I can't factor anything else out of it. But I can factor something in the denominator. And unfortunately, I have a 3 in front of my lead coefficient as my lead coefficient, which is not 1. So I'm going to have to do my factoring a little bit different. I'm going to go ahead and bring my 3x squared out and bring my -4 out. And the next thing I'm going to do is make my x and say, okay, what two numbers multiply together to get -12 and add together to get a +1? And I know that's going to be 3 times 4 makes 12, but it's got to be negative, so I'm going to put my negative sign with my 3 there. That will end up giving me -3 plus 4 will give me a +1. So what I'm going to do is take this +1 right here, and I'm going to change it to a -3x plus a +4x. And that way, -3x plus 4x equals +1. So I've just rewritten it a little bit different. Now I can factor some things here. If I group these two together, I can pull out a 3x, and that leaves me with x minus 1. And over here, the same thing. If I pull out a 4, that leaves me with x minus 1. So what I end up having is I can actually factor these out of my problem now. And so I'm going to have 3x plus 4 times x minus 1. So let's go ahead and write this all out so we can see it clearly. So in our numerator, we have 3x plus 4. And in our denominator, we also have 3x plus 4 times x minus 1. And so, happy days, I can actually cancel these two out, leaving me with just 1 over x minus 1. Now, that's my simplified, and it says identify any x values which the expression is undefined. So here's where you have to be really careful. Even though this is our simplified answer, we have to look over here to find our undefined, the values for x, which would make it undefined. And in this case, let's set them both equal to 0 and solve for 0. We have 3x equals negative 4, so x equals negative 4 over 3. So when x is negative 4 over 3, this whole term becomes 0, and that would make our entire expression undefined. Let's check the other one. X minus 1 equals 0, so add 1 to both sides. So when x equals 1, this piece would now be 0. And now our whole expression would be undefined again because we would have a 0 in the denominator. Therefore, what we can say is the expression is undefined when x equals 1 and when x equals negative 4 over 3. Because these values of x make the factors of x minus 1 and 3x plus 4 equal to 0. All right, and the great thing about math is that we can actually check our work to find out if we're correct. So we can just substitute x equals 1 and then another time substitute for x equals negative 4 over 3. When we substitute for x equals 1, we end up getting 7 over 0, which we know is undefined, so we know we got the problem correct. If we substitute when x equals negative 4 over 3, once again, we get 0 over 0, and that, again, is undefined. And so those are our two x's, values for x, that would make the equation or the expression undefined. All right, one more for you to try on your own. Turn your video off and give this one a try. All right, so as you were doing this one, the factoring is just a little more challenging on this. We have to take a look at these two since this is not a 1 in front of our x squared. And what we're going to have to do is factor this out. So I'm going to pull this out a little bit and say this is going to be x squared, and I got my 2 over here. Now I need to look at two numbers that multiply together to get 12. So I'm going to make my little x, multiply together to get 12. Add together to get 7, and that's an easy one. That's going to be 3 and 4. So I'm going to change my 7x to be 3x plus 4x, and then finish up my equation here. And now I'm going to group together and see if I can factor by grouping. And here I see that I can, in this first equation, I can go ahead and factor out a 3 and an x. So that leaves me with 3x is 2x plus 1. And now on this one, I can factor out a 2. So that leaves me with 2x plus 1 also. So in the end, my numerator is going to be 3x plus 2, this one and this one, times 2x plus 1. All right, now let's simplify by factoring the denominator. So again, I have a 6 in front of my x squared, so I'm just going to go ahead and expand my equation a little bit to say 6x squared and put my negative 6 over here. Again, I want to factor, so I'm going to say two numbers that multiply together to get negative 36, add together to get negative 5. This one might not be quite as quick for you, but it's negative 9 times 4. So let's go ahead and change our negative 5x to be negative 9x plus 4x. We know that equals negative 5x. And then we have the rest of our equation written in here. I'm going to go ahead and put that in. like this. So now we can factor out of, after we group, we can factor now. I see that there's a 3 and an x I can factor out of this one. That leaves me with 2x plus a negative 3. And in this particular part, I can factor out a 2, and that is going to also leave me 2x minus 3. So the simplified version on the top is going to be 3x plus 2 again. Here's my 3x plus 2, and then 2x minus 3 on the bottom. So I can see that I can actually factor out or divide out to simplify those two, and that leaves me with 2x plus 1 in the numerator and 2x minus 3 in the denominator. Okay, so there is my simplified part of it. Now I have to identify any x values for which the expression is undefined. Well, it's good to go ahead and check on this one. So 2x minus 3 equals 0. Add 3 to both sides. We have 2x plus 3 equals, positive 3. And then divide both sides by 2. And we have x equals 3 over 2. Okay, but I'm not quite finished yet because this isn't the only one. I have to pay attention to this piece of my equation because that would be important too. So I'm going to have to also say 3x plus 2 has to equal 0 in order to find the expression and make it undefined. So we're going to subtract 2 from both sides. 3x equals negative 2. Divide both sides by 3. So x equals negative 2 over 3 also. So what that tells us then in the end is the expression is undefined at x equals negative 2/3 and at x equals 3 over 2, because these values of x make the factors of 3x plus 2 and 2x minus 3 equal to 0. Okay. The great thing, as I said before, you can always check your work by substituting. So we're going to substitute these, the 3 over 2, and when we do that, we end up with a 0 in our denominator, which makes our expression undefined. And when we substitute with negative 2 over 3, we also end up with 0 in our denominator. So that tells us that both values of x in the division by 0, which is undefined. Okay, this example is pretty much the same, but this time I'm going to show you how we can use negative 1 to help us in this. So the first thing we want to do to simplify is go ahead, we can factor out an x out of this first term. So that leaves me with x times 4 minus x. And on the bottom, when we factor this, two numbers that multiply together to get negative 8, add together to get negative 2, I know is 4 and 2, but the 4 has got to be negative. So that's going to leave me with x minus 4 times x plus 2. All right, so let's go ahead and write that in there, x minus 4 times x plus 2. And in the past, we were able to just cross some things out, but notice how closely we can't cross these out exactly yet because 4 minus x is not the same as x minus 4. But I know that if I were to divide both sides in here by negative 1 on the top, so I have x times 4 minus x, if I were to factor out a negative 1, that would leave me with negative 1x times negative 4 plus a positive x now. And so now I can rewrite that to say negative 1x times x minus 4. And now if I bring my denominator over, I have x plus 2 times x minus 4. Yay, now I have an x minus 4 that will both cancel out. So the simplified expression is negative 1x over x plus 2. All right, so now the next tricky part is to identify any x values for which the expression is undefined. So let's see, x plus 2. What happens when x plus 2 equals 0? Well, if x equals negative 2, the whole thing becomes 0, so that would leave it undefined. And don't forget, even though we canceled it out, we still have to account for it. X minus 4 equals 0, so when x equals positive 4, the whole thing would be undefined also. So in the end, we know that the expression is undefined at x equals negative 2 and at x equals positive 4. All right, and once again, we can always check. And another way that you can check, I showed you before where you could just substitute in, but another way you could do is type this into your calculator using your y. We could go ahead and for y, we would put in our 4x minus x squared and divide that by our denominator here. It would continue out there. And then for our y2, we would put in the answer, which we found to be this. And when you go to your second table and look, you will see when x is -2, we get an error. And when x is positive 4, we also get an error. So there's our two errors, so we know that we did it correct because it's going to show us an error when something is undefined. Okay, here's another one for you to try on your own. Remember, we're working with factoring out a -1, so turn your video off and give it a try. Okay, so on this one, the first thing we want to do when we're looking at this is I see we can factor a 2 out. That's going to leave me with 5 minus x over x minus 5. And I can see that I can actually factor a -1 out of the top, and that's going to help me. So I'm going to have my 2 that I just factored out. I'm going to go ahead and factor out a -1, and that's going to leave me with -5 plus x. So I'm going to go ahead and rewrite this as -2 times x minus 5. And I'm going to bring my denominator all the way over, x minus 5. And I can see that I can cancel these two out, so my answer is -2. That's my simplified answer, okay? So I've got that part done. Next, I have to identify any values of x for which the expression is undefined. And in the denominator, there's only one, so x minus 5. If that equals 0, x would have to be 5. So I know that when x equals 5, the expression is undefined. The expression is undefined at x equals 5. And once again, all right, so you can put this in your calculator to check it. So we're going to put in y1. Let's go ahead and put in y1 is this part, and y2 we'll put in as our -2. So when you put that in your y1 and y2, and then we go to table, we see that when x is 5, there's an error. And so that tells us that we did our problem correct. All right, here's another one for you to try on your own. Remember, we're working with factoring out -1. So turn your video off and give it a try. Okay, on this one, let's talk about factoring out our -1. So let's go ahead and take out a -1x on the numerator, and that's going to leave me with x minus 3. Okay, so now let's talk about our denominator. It's not quite as easy to factor out, so I'm going to expand. Okay, so I'm going to have 2x squared and a plus 3 on this side. Now I need to find two numbers that multiply together to get 6, which is 2 times 3, and add together to get -7. And so I know that's a -1 times a -6. So instead of saying -7, I'm going to rewrite that as -1x plus -6x. All right, now we're going to group our terms together and see if we can factor some more. So here I have a 2x squared minus 1x, and I know that I could factor out an x out of that, leaving me with 2x minus 1. And over here, I could factor out a -3. That would leave me with a 2x minus 1 also. So now I can factor out this 2x minus 1. So it's going to equal 2x minus 1. And I have an x and a -3. So x minus 3. So in the end, I have a -1x times x minus 3, which was this part right there, divided by 2x minus 1 times x minus 3. So I already dealt with my minuses. So now these will cancel out nicely, and my simplified expression is -1x over 2x minus 1. So there's the simplified. The next part, we need to identify the x values for which the expression is undefined. Remember, an expression is undefined when there's a 0 in the denominator. So let's go ahead and see what number would that be if I set it equal to 0. 2x equals 1, and divide both sides by 2. So when x equals 1/2, that would make our expression 0. But don't forget, I also, even though I canceled it out, I still have to deal with this x minus 3. So when x minus 3 equals 0, then x would equal positive 3. So in the end, we know that the expression is undefined at x equals 3 and x equals 1/2. And the fortunate thing is about math is we can always check to see if we did things right. So let's do that. In this one, you could easily just put it into your calculator. Let's go ahead and put in this as y1 and this as y2. And when we put those in there and we look at our table, we see when x is 0.5, which is 1/2, we get an error. And when x is 3, we also get an error. So we can see that both of those give us errors so that we know we did our problem correct. And that is the end of multiplying and dividing rational expressions part 1. Go ahead and take a break and then come back for part 2.